Good afternoon, teacher. My name is Al-Amine. I'll be doing the homework number 2. So let's get started. We'll start by the exercise number 1. Here we have to find the transfer function for the circuit. So we have to find, first of all, the R equivalent. We have here 2 R equivalent 1. That's equal to R1 plus 1 over SC1, and so the R equivalent 2 that's equal to R2 plus 1 over SC2. So I will try to draw this in another shape. For example, we have Vin in here, we have R1 and V out in here, and so we have R2 in here, and that's the ground. If we try to find the V out in here, we will have V in multiplied by R2 over R2 plus R1. This formula is a voltage divider that will apply for the same circuit in here. We have here E2 that represent our V out E0, and E1 or E in here that represent our V in. We will multiply by R equivalent 2. We have R2 plus 1 over SC2, and so in the denominator we have R2 plus 1 over SC2 plus R1 plus SC1. So I'm trying to make them in the same denominator. Let's start by numerator first. So E0 is equal to R2 SC2 plus 1 over SC2, and in here we will get R2 plus SC2 over SC2. Now R2 time SC2, I'm sorry for that, plus 1 over SC2 plus, here we have R1 SC1 plus 1 over SC1. We don't have to forget our multiply by En or E1. Let's move. Here we have A0 is equal to R2 SC2 plus 1 over SC2. We will make them in the same denominator. R2 SC2 plus SC1 plus R1 here we will have S square C1 again plus SC1, and we have the other one is plus R1 SC1 S square, SC1 SC2 plus SC2, all of them over S square SC1 SC2 without ignoring the En that we have in here. So that's equal to, we will simplify those C2 and also the square one. So we'll have R2 SC2 plus 1 over R2 square C2 C1 plus SC1 plus R1 S square C1 C2 plus S C2 multiplied by En all over in here SC1. So this one is equal to multiplied by En. That this amount will move to the denominator here, So we will have r2 s square c2 c1 plus s c1. We will have this one, and in the denominator we have r2 s square c2 c1 plus s c1 plus r1 s square c1 c2 plus s c2. That will definitely equal to, we will take s here and here, that will give us r2 c2 c1 plus c1 over, we will take s in the s in the denominator too. That will have r2s c2 c1 plus c1 plus r1s c1 c2 plus c2. We will simplify them, so we will get r2 c2, that will be multiplied by en, r2 c2 c1 plus c1 over, here we will have r2 sc2 c1 plus r1 sc1 c2 plus c1 plus c2. That will be multiplied by en. Though if we bring the en in here, the system will be equal to r2 c2 c1 plus c1 over, if we take s in here, we will have r2 c2 c1 plus r1 c1 c2 plus c1 plus c2. That will be the final answer for the exercise number 1. So let's move to the exercise number 2. Exercise 2. Obtain state space model. The exercise number 2 is about obtaining the state space model. So let's start. I have to draw this in here. We have rs is positive and negative in here. I have here 1 over s, here is 10 s plus 5 ys, and this one is 1 over s plus 1. So let's get started. This one and this one will give us the transfer function gs here. This one and this one will give us like let's draw it a little bit smaller in here. This one will give us 10 over s plus s5 though we create a transfer function in here. So this transfer function will be like 10 over s factor of s5 over here 1 plus 10, and here we have s plus 5, s plus 1. We have to reduce them in the same denominator, so we'll have 10 over s to the and this one will be s plus 5 s plus 1 plus 10 over this amount. So I have to simplify those ones, and our equation will be like 10 over, and here we have s plus 5 s plus 1 plus 10, and in here we have it's remain as only s plus 1. So this s plus 1 will move to the denominator in here, so the equation will be 10s plus 10 over s cubed plus 6s square. So you have 6s and plus 10. So that is our g transfer function. Let's search for this one, the derivative of x1 over x dt, derivative of x2 dt, derivative of x3 dt. Depend to our equation, we have in here 0, 1 and 0. Here we have 0, 0, 1, and here we have minus 10, minus 6, and minus 6. This x1, xt1, x2t, and x3t. What about ut? Here the ut will have 0, 0, 1. So the final answer will be ut like 10. You have here so 10, you have 0 xt. That's the second exercise. Let's move to the third one. The third exercise, let's take a look. It's about the diagram reduction. Yes, diagram reduction. We have here x positive, negative. This one you have here g1 positive, negative. You have feedback here h3. You have here also g2, here g3. You have y in here. I have in here h2 that will be linked to this, and also in h1 that will be linked to this one. So that's our diagram, and we will try to reduce in a simple form. So let's get started. Here we'll have g1, this one will become, we have a transfer function, so that will be g2 over 1 plus g2 g3 h3, and we'll have g3 in here, y. The feedback h2 will be in here, and so the feedback h1 will be over there. Okay, that will be like here we have the sign positive, negative, g1, and those also create feedback between h2 and our transfer function that we have above. So that will give us a transfer function like g1 over 1 plus g2 g3 h over 1 plus g2 g h, okay, g2 h2 over 1 plus g2 g3 h3. That's one transfer function, and have our g3 in here, y, and the remaining feedback h1 will be linked to this one. So our x will be, if we involve the g1, here we'll have g1 g2 over 1 plus g2 g3 h3 plus g2 h3 divided the whole divided by 1 plus the transfer function g1 g2 h1 over 1 plus g2 g3 h3 plus g2 h2, without forgetting our g3 that we have in here and h1. So by involving the g3, we'll have a final answer that will be g1 g2 and g3 over 1 plus g2 g3 h3 plus g2 h2 plus g1 g2 h1 and y. The y over x will be this answer, g2 3. Let's move to the final exercise. The final exercise have two parts. The first one is about drawing the SFG diagram. So we have those information in here. Have minus h1 a3 y5 y3 equal to g1 y2 and y4 is equal to g4 y2 plus g2 y5. So y5 is equal to j3 y4. So the drawing will be like we have one in here, we have y2, here will be g1, here y3 g2, we'll have j3 in here and y5 So depend to those information, we will have h1 is between y2 and y3, so we have h1 in here, and h3 is between y2 and y5. Let's put like y5 in here. This will be h3 reversible, and g4 is between those. We have h4 in here. Yes, y4, sorry, that will be g4. And then so we have between g4, y4 and y5 we have h2 also. So those transfer function will be like that, and single loop will be like y2, y3, h1 as the loop number 1, and the loop number 2 will be y4, y5, h2. The loop number 3, y2, y5, h3, and so the loop number 4 will be drawing like this. Loop 4, you have h3 in here, y2, y5, and this one is y4. So the first question, the question number A is done. I will move to the next question, B1. So it's about finding y5 over y1. So we're trying to use this formula. The sum of nk goes to 1 mk delta k over delta. So we have to find mk delta k delta to get the final answer. So mh will be like g1, g2, g3, and the other one will be that will equal to g4, g3 of minus g1 minus h1 minus g3 hl minus g1, g2, g3, h3, and minus g4, g3, h3. The nth will be g1, g3, h1, h2, and find delta 1 will be 1 minus 0, so it's equal to 1. Delta 2 is n minus 0, 1 minus 0, so it's equal to 1. And delta is equal to 1 plus h1 g3 g2 plus g1 g2 g3 h3 plus g4 g3 h3 plus g1 g3 h1 h2. So the final answer 5 over y1 is equal to g1 g2 g3 plus g4 g3 over delta. Our delta is this one.